Okay, so welcome to lesson 1 for Algebra 2. In this lesson, we're going to be talking about polygons, triangles, and then we're going to talk about transversals, and then also scale factor and proportional segments. So in this book, we go along with the Algebra 2 Saxon book. I believe it's the 3rd edition. And the first part of this lesson 1 talks about polygons. We're going to kind of skip over that. Basically, polygon means many angles, and so we're referring to shapes. That's a polygon. And then it goes on to some further detail, but we're going to kind of skip over that because we don't really need to discuss that in detail. So I want to jump into triangles. First off, we're going to talk about classifying triangles according to the angles. And so in this case, we have 3 types. We have right triangles, obtuse, and acute. And so I've drawn one of each right here. This first one, this is a right triangle, and we know that because it has a right angle. This is an obtuse triangle because it has an obtuse angle. Remember, obtuse is an angle that is greater than 90 degrees and less than 180. And then this is an acute triangle because all 3 angles are acute. So that's how we classify triangles based on their angles. And then another helpful tip in dealing with triangles, always, all 3 angles are going to equal 180 degrees. That is the definition for angle measurement of a triangle. Always. So keep that in mind. Every single time you're dealing with a triangle, they have to equal 180 degrees or else we went wrong somewhere. So another helpful tip that we can know from triangles is the relationship between angles and sides. And I'm going to refer to this obtuse triangle. The angle that is the largest is across from the side that is the largest. In this case, this angle, my obtuse angle, is bigger than the other 2. And also, the side opposite of it is larger than the other 2 sides. Same thing can be said about the smallest. The smallest side is going to be opposite of the smallest angle. Another way that we can classify triangles is by their sides and their side measurements. So we have scalene, isosceles, and equilateral. A scalene triangle means that none of the sides have the same measurement, just like in our obtuse triangle that we were working with in the previous example. An isosceles means they have 2 sides of equal measure, which would be like our right triangle. Not always a right triangle, but it is often one that we will see. And then an equilateral means all 3 sides have equal measure, like we see right here. Equilateral also means equal angular, because if all 3 sides had the same measurement, that also means all 3 angles had the same measurement. And we said that all triangles, their angles will equal 180. So when dealing with this, we know that every single time our angle measurements are going to be 60 degrees each, because 180 divided by 3 is 60, and they have to all be the same because their sides are the same. So that's a nice little cheat for that. So let's do some practice. In this example, we have a triangle where we have one given angle, and the book wants us to find the value of the x and y. We know that all 3 of these are going to equal 180. 50 is already given, so if I subtract that from 180, I'm left with 130 degrees. So 130 degrees is going to be the values of angles x and y combined. I'm going to keep that in mind. I also know that these 2 sides have equal measure. So if the sides have equal measure, their opposite angles also have equal measure. So that would be the 50 and x, because we said with all that relationship stuff that we said at the beginning. So if we know that these 2 have matching side lengths, then they also have matching angle measures. So the measurement for angle x is going to be 50 degrees. So now we need to find angle y. We know that angle x plus angle y has to equal 130 degrees. We know that angle x is 50, so I can subtract that. Then I get 80 degrees. And if I need to check my work, I can add all 3 angles together, and I'll find that I do still get 180 degrees. For our next example, we're still dealing with the triangle and those rules that we just learned, but we're also adding in something that we learned from our review, reminding us that a straight angle equals 180 degrees. So they tell us this given angle and this one, and now we're just going to do deductive reasoning, and a little bit of adding and subtracting, and we'll be done. So if we know that this whole part is 180 and this is 150, we know our missing angle is 30, because we know that 30 plus 150 equals 180. Okay. So if we know that x is 30 degrees and are given 40 degrees, we know that those two combined is going to be 70. Plus whatever angle y is, it's going to equal 180 degrees, because triangles always will equal to 180 degrees. So now we can just subtract the 70. And our missing angle is going to be 110 degrees, and that's all we need to do. Our next concept in this book is going to be talking about transversals. Transversal is when you have two parallel lines as indicated by the arrows that are not at the edge of the segment, they are within the line. So that tells us that these two lines are running parallel to each other when both of these lines are intersected by a third line. That is when you create a transversal. And what we remember with transversals is the most important thing you have to remember is that a straight angle is 180 degrees, also known as a straight line. So in this case, both lines are being cut at the same degree, which creates a lot of congruency and supplementary angles. So the way that you can often just make a shortcut in your brain is to remember larger angle and smaller angle. Because as you can see here, we have obtuse, acute, obtuse. And so we can just mark that with an L and an S for larger and smaller. So looking at this, we see that we have four sides that are four angles that are all obtuse and four angles that are all acute. And what we can know automatically in our brain is that all four of those small angles are congruent and all four of those large angles are also congruent. So you only need to know one angle and you can find the missing 7. So let's do some practice. Okay, so in this example, we have parallel lines M and N that are both being cut, and we have a given of 60 degrees, and then we have 3 missing angles that they want us to find. So what we can do first is we can find A, because we know that it is adjacent to 60 degrees. So if those two angles combined is going to be 180, we just subtract 60 from 180. So we know that angle A is 120 degrees. So now that we know that, with this other line and intersection, we just need to ask ourselves, okay, is the angle that I'm looking at acute or obtuse? And then we can know our answer. So B is an obtuse, so it's going to be the same as A. And C is acute, so it's going to be the same as our given. And that's it. That's simple. Our last concept in this lesson is going to be scale factor and proportional segments. Here we have 3 lines that are being cut by 2. And so these 3 lines, it's important to note that they are parallel as indicated by the arrow within the line segment. And we see that they've already given us 3 of the segments, but we don't know this one. That's our unknown. So what we're going to do is we're just going to set this up like it's a ratio. And I'm going to go with part 1 over part 2 is equal to part 1 over part 2. It's very important that we keep that consistent. Consistencies keep. If you're gonna do the top part first, you have to do the top part first again. You can't do 2 over 3 and then x over 3. That's not consistent, and you have to be consistent. So now, with this part, we're just gonna cross multiply. So we have 3 times 3 is 9, and 2 times x is 2x. We need to get x by itself, so we're going to divide by 2. And our missing segment is 9 over 2. And that is how you find proportional segments. So let's do some practice. Here we have another situation where we have 3 parallel lines that are being intersected by another 2. And so we're just going to set this up as a proportion. So we're going to have the first part over the second, first part over the second. Okay, so now to solve, we're just going to cross multiply. 5 times 8 over 3. So So that's going to be 40 over 3 equals 2x. And we're trying to get x by itself, so we're going to divide by 2. Or in this case, we'll just multiply by the reciprocal. Okay, and I know that 2 and 40 can both reduce, so that's going to be a 20 and that's going to be a 1. So we are left with x equals 20 over 3. And we just found our missing segment. So we're done. Well, that's it for lesson 1. Be sure to leave any questions that you have, message me on Remind. Let me know if there's anything that we need to go over in class. More than happy to do it.